Assuming we have two methods, we have connect method connect and method disconnect, and we would wish to work with conditional statements to control how the flow of execution in when it comes to those methods. Then let's work with an integer connection time and another method check connection. Within check connection, we are working with the if then statement to check that the connection time is equal to 10. Then we should disconnect. So I'm working with this print s out statement here so that we could see if the then statement part of it worked. So if this is true, then it should disconnect, and you should also see the output. I'm gonna run this. Expect to see if then disconnected. There you go. Okay. So if I was to use a different value in connection time, like 15, then I should not see any output because connection time exactly there's no output because connection time is not equal to 10. So that is the if then statement. In whatever logic you're trying to evaluate, it should be if true, then do the following. So I'll just get this out of the way so you can keep it simple. Then we have this other way of writing it, this syntax. So instead of working with curly braces, sometimes people would prefer to work with it like this with indentations. This can also work, and it's very good if you are going for concise code and you don't want to work with curly braces and it's just one statement. However, be very careful with this approach because if you need to make any changes later, you can get logical errors where the code will run, but it will result into undesirable output. So be careful when you're working with this kind of approach and you need to add more code. Okay, then we have if then else. So it's very similar to if then, but then it has another branch, else statement. So if the connection time is 10, disconnect. Okay, so if that is true, disconnect. Let me put an s out here to test that. If then else disconnected. Otherwise, if this is not true, then connect. So let me put this to test that. So if then else connect. Okay. So right now the connection time is 10. Again, go back to show us that the connection time is 10. So this should be true, which means we should only get this part as the output. But then if it were not the case, I should see the other one. So if then else disconnected, correct. Otherwise, if the connection time was a different value other than the expected, the checked condition here, then it will print the else branch. There you go. So if then else connected is printed because this did not evaluate to true. Connection time is currently 15. So if connection time is equal to 10, then disconnect and print this. Otherwise, do the following. Okay, so it's going to the else branch because it didn't evaluate to true. That is how if then else works. And in typical sense, when you're running production code, then it might be that you're working with methods such as this to run some conditions. Welcome to decision making statements. We will look at demos on if then else, switch. The most common approach that you will see when you are getting started in code of if then else is this grade checking. So let's go to print grade. We have a test score of 76. and character grade. So we are checking if the test score is greater than or equal to 90, print and set grade to A. Else, if it's greater than or equal to 80, set it to B, and so on and so forth. So given that it's 76 is greater than or equal to 70, then it should print grade C. The reason behind this logic is that the if then else logic stops once it finds a condition that meets what it's checking. So it went outside of the loop the moment it found grade C applies to the condition, and that was it. So that's the logic. Let me just represent that to you diagrammatically. In if then, so we start, if the condition is true, then it does something and then stop. If it's false, it goes outside the loop. If then, in if then else, it starts, if the condition is true, it does something, then it stops. Otherwise, if the condition is false, it does something else, then it stops. In the official documentation as per Java 8, and also in the links attached, which is the reference that I'm working with, you'll find that if then else is still classified, or else if is still classified as if then else. But this is the logic behind else if, so I wanted to make it clear for us here. So start, if the condition is true, it does something, then it stops. If it's false, it checks for the next condition. If that condition is true, it does something, then it stops. If it's false, it checks for the next condition. If that is true, it does something else, then stops. If it's false, then it will do what is in the else block alone. So like in our example in code, we had greater than or equal to 90, greater than or equal to 80, greater than or equal to 70, greater than or equal to 60 somewhere here. So let me just put it hanging in the air. Then we had this block of else f, right? So greater than or equal to 90 didn't apply for 76. Greater than or equal to 80 didn't apply for 76. Greater than or equal to 70 applied for 76. Greater than or equal to 60 also applied for 76, but f did not apply. So the reason why it did this, greater than or equal to 70, was the one that was printed and not this one, is because of this logic. So let's start again using that specific example. If this condition is true, then do this. It was false, so it went and checked for the next condition. If this is true, then do this, which was supposed to be 80, but that was false, so it went and checked for the next condition. If this is true, then do this, 70. So it did it, then it stopped. So on switch decision statements, let's look at this method, print month if. We could print the month that whose value amounts to 8 using this kind of fashion, where at each instance we check the month value and then we set the month string value after that. So this is an else if way of doing it all the way up to the end where we print month string. So I'll go to the main method. I expect this to be August. Let's see, print month if. Print month if. Here we go. I run this, I should see August. Here we go. Okay, if it was any other value of any other month, then I should have seen that month. So this is an else if way of doing it, but there is a switch way of doing it, and this is how it looks like. So we still have the month value, we still have the month string, we have the condition working with the month value and the case. So on case 1, set the month to January, then break. On case 2, set the month to February, then break, and so on and so forth. So if case 1 is not true, then it will check the next case and the next one and the next one all the way up to when it meets August here and go outside the loop thanks to the break statements. So I'll be running print month to check that out. Print month, and that August. Okay, let's go back. So the break statements are useful because if you don't include this break statement where the target case is, then it will fall through until the next break statement is found. So if I run this right now, it will print September because September is the one that has the next break statement, i.e. the loop has fallen through the next one until it finds the next break statement. If I remove the break for September and the break for October, then it will go and fall through to November, and so on and so forth. Another good example of fall through is this method here, method fall through, where array lists, of type string by the name future months, and the array list is then added a month on each case. Please note there are no break statements on any case apart from the last one and the default one. So if the value is 8, then we expected that August will be displayed, but because there are no break statements, it will fall through and we will see August, September, October, November, December. Otherwise, if I had a break statement here, then after it meets the matching case, it should go outside the loop. So we should only see August. But this can be useful in such a case where you want to add everything that follows after the value after the case is a match on one of the conditions. Like in this case, we wanted to add every future month after the month of August, and so there you have it. We'll look at clips on the next session, but before we get there, so we're checking if the future month is empty, then we should print a valid month number. Otherwise, look through the future months. So you have your month name and the future months, and then you print the month name one by one. So August to December. So there is a more concise way of doing what we've just done above, where you can set the value of the month string directly to the result that will be evaluated from the switch statement. So you have switch and then the condition, then in the brackets you have this form here, rows pointing to the evaluation that should be set as the month string value all the way up to the last one. Then the default is invalid month. So when you're printing month string, it will print August, but the value is to 8. The reason why these ones do not have break statements is because with the new syntax, not really new, but okay, it was supported from later Java versions. So with the new one, where we have the arrow, then the break statements is not necessary because the arrow here has no fall through behavior, whereby if it finds the matching case, then it will work with just that and nothing else in the switch block. Okay, you can also work with case statements that are string values. It's not a must that they are numbers like we've done so far. Like in this case, you take the month value that is entered and then you set it to a lower case. So this is a public static method that expects a return type int, and it expects you to pass in a month value of type string. So what it will do in the switch statement is take the value and convert it to lowercase for easy matching in the cases, and then to return the month number. So eventually the method returns a month number, being an int type of method that is accurate. So we work with this. The string month is August with capital A. The returned, the get month number is then invoked, and the month is passed in, and it's set to an int because get month number returns an integer. Then if the return month number is 0, then we are printing the valid month, otherwise we are printing the returned month number, which should be an 8. Let's run that. There you go, 8 is alright, done. Finally, we have multiple checks. So sometimes you might wonder why would you prefer working with if-else over switch, which seems to be more concise. But in some cases you might find that you'll need to use if-else still, like in this case where you have more than one conditions to check. So we have if number entered is greater than 6 and if number entered is less than 12, then we have to the year, otherwise where are we? So that's it on switch decision statements, but I will not run without showing you the switch leap year example, which is very common. So we have int month 2, which is the month of February. We have int year 2028, which we want to check is a leap year or not. Then we have int number of days that do will initially. So switch month is checking for these cases here, case 1 through 12, 1, 3, 5, 7, 8, and 12, whose month have 31 days, then it breaks. Then case 4 and case 6, case 9 and 11, the month days are 30, then it breaks. Then with case 2. So this is the condition for checking the leap year. It should be divisible by 4 but not divisible by 100, or divisible by 400. So if we're talking about 2028, is it divisible by 4? Yes, it is. This should give me 5 or 7, if I got that math correctly. It's not divisible by 100, that is correct. So this entire statement from end to end, given that it's a double AND, logical AND, the value is to true, or it's divisible by 400, it's not true. So given that there's an OR statement between this side and this side, then it will still set the value to 29 because this side is true and this side is false, but an OR statement will execute either way as long as one of the sides is true. So that is what. Let's try and work with a year that is definitely not a leap year. Like let's do 2022. So is it divisible by 4? Nope. It's not divisible by 100? Yes, but this is false. None of them, both of them are not yet true. Then is it divisible by 400? No, it's not. So we should expect that to give me number of days to be 28. The else value there is definitely not a leap year. And that is how it works. So to understand the logic behind this, let me also walk you through the diagram. So with the switch statement, you have a start here, then checking the switch condition, then checking the case. So if case 1 is true, then you do something and break. However, if you're working with the arrows, remember the break statement is not necessary. Then if case 2, if this one is false, it goes to +2. If it's true, it does this and break. If it's not true, all the way down, it goes to a default value that does something or break. Then, so if it's true, it's supposed to stop. If it's true, it's supposed to stop, and this one will definitely stop after it's reached the end of the evaluation. So this is the logic behind it. Yeah, I'll be seeing you on the next one with the loops.